Alright, so more often than not, you're going to be faced with a partial fraction expansion problem, and as an electrical engineer, this comes up frequently in the lumped parameter circuit analysis. So what you would have here is you'd have, in the S domain now, some polynomials on the bottom, and as long as you can determine that they will be real roots and not complex, having an I in there, then our TI-89s can quickly and easily handle these and expand these out just for quick inverse Laplace analysis even. And I'll show you how to do that really quick. So we have this equation right now, and I'm just going to show you now that I have that here right there, s plus 6 over the quantity of s times all of that. Now, something to notice here is that this has a repeated root right here. This root is getting repeated so that you have basically this on the bottom. And anytime you have this, you know that one of your solutions in the end is going to have, basically this plus, all of that is going to be under something, but it's going to trickle down like a normal expansion polynomial would. So doing that, what we do is you literally just hit the expand command, and that can be found by going up to the algebra menu and you go down to expand right there. So once you click on that and you get that into your terms, you then literally just put that entire expression in there just as you see it. And that is what you see right there. It's just that one operator, and it then spits out every single coefficient. So now what you would have here, so you'd have -1 over 4s plus 3. You'd have -7 over 4s plus 1. -5 over 2s plus 1, and so on. So you would then take each of these individual ones and you would inverse Laplace them. So this would be, -1/4 e to the -3t. This would be -7/4 e to the -1, -t. So you would go through this whole lineup and process and do that, but all you have to do is just hit the expand button. And as far as I am aware, these equations, the TI-89 can handle pretty much any system of real and repeated roots. I mean, this could have just as easily been a 4 on the bottom here. So if I had changed that to a 4, it'll think about it, but it'll spit it out here. So true to form, we have a squared term, we have a cubed term, we have a to the 4th term, and a normal, all the way down to 1. So it does the whole way. I could even add in one more term just for fun. Let's do s minus 20 on the bottom here, just to randomly add it. See the choose on that. Oh, that's ugly. But you didn't have to do that. The calculator can do all of this. So there you go. As long as it's not a complex root, you're covered. And I cover how to actually tackle one of those in my other video. So have fun.